Hello, my name is Vikas Sinha. This is a presentation of my final project, which I did for the Data 607 course at the City University of New York. The aim of this project is to investigate the relationship between the amount spent on public education and the number of patents filed per capita in a country. The point of this investigation is that if we find that more expenditure on public education leads to a greater number of patents filed per capita, then that would increase the priority of the money spent on public education and make it more worthwhile and would be a useful information for economic policymakers. For this project, I used a linear regression model to determine correlation among the variables, as I will explain later. The following data sources were used. I used Wikipedia for some preliminary information. I used the World Intellectual Property Organization for information on patents filed per country, by each country. I used the World Bank Group site to find the public education expenditure information for each country. So let me go through the flow of this project and what it does. So in the very beginning, I selected the countries to include in this study, and this was just available from Wikipedia. This is a list of the countries that file the most patent applications per million for each million people in their population. As you can see, the 6 countries are listed here. This is just a preliminary investigation to just find the number of countries that we will be investigating. So the next step is to find the patents filed by each country, and that I obtained from the World Intellectual Property Organization site. And then, I used the dplyr code to perform substitutions on the data to get it into a form where I can get the patent counts of that data. The graphs that we see below, the 6 graphs, they show the raw patent counts filed for each country. It's important to realize that these are not normalized for the population of each country, and so these just give a rough view, a quick and dirty view of the patent numbers filed for each of the 6 countries for the years selected. The amount of expenditure on public education for each country is then obtained from the World Bank Organization, and I show the code here to do that, again using the dplyr routines. The population growth data is necessary to convert the raw patent counts to patents filed per million population, and this I obtained from Wikipedia. The per year population numbers are not available, so I used an approximation for that. I used the population counts, the mean of the population between the years 2010 and 2015. In the next part, I plotted graphs using ggplot for each of the countries. So these are side-by-side plots, as you can see for each of the 6 countries. The important thing to realize is that there is no one trend that seems apparent looking at these graphs. Some countries have an inverse relationship, in fact, and some show no particular trend. So I then selected 2 countries from this model to do a regression analysis and to see if a regression model can be done and what that model might tell us. So again, this is a relationship between the amount that is spent on public education and number of patents filed per capita. The amount is expressed as a percentage of the GDP. So I built a linear regression model using this very simple relationship, and then we see that although the adjusted R-squared values for both of these countries are very high, which is a good thing, we find that the coefficients of the independent variable have opposite sign, which suggests that there is no single model that could apply to both. Looking at the residuals, there is not a clear trend among the residuals, which is good. Finally, my conclusion is that the available data did not show a clear relationship between the independent and dependent variables. In other words, between the level of expenditure on public education and the number of patents filed per capita. It is possible that because my model was simple, it is possible that other global factors or macroeconomic factors needed to be included. And it's also possible that the number of patents is affected by the private industry efforts, which would not necessarily be included in the factors in my independent variables. So the challenges that I faced here is that the population growth data was not available on a per year basis. And as I mentioned earlier, I used the mean between the 2 years. And some data for some of the countries, the data were not really available. So I did the best for the data that was available. Parsing the data took a while. The web scraping part took a while, and I learned how to use the RVest package. The earlier package that I tried to use, the Wikipedia RPAT package, was cumbersome and not as easy to use. With that, I conclude this presentation. Hope this was useful. Thank you.